Hi everyone, in this video we're going to go through the difficult questions from exam 2, just focusing on multiple choice questions. So I've got 22 multiple choice questions where the percentage of students who got the answer correct was 50% or below. Some of them it's 51%. So we're focusing on these because I'm going to assume, questions where the majority of students got them right, you probably know how to do them, or you could probably work through them. But these questions are a little bit trickier. I encourage you to pause, have a go at doing it on your own, and then watch the solution. Okay, so let's get started with question 1. So we've got a continuous random variable. Might just get my highlighter up. And it's a normal distribution with a mean of 20 and a standard deviation of 6. And Z is the standard normal distribution. So remember, standard normal distribution has a mean of 0 and a standard deviation of 1. Okay, so remember, mean equals 0 and standard deviation equals 1 for the standard normal distribution. Okay, so if Z is, if the probability of Z between -2 and 1, if we can find what that is equal to, then we've got to see, well, that is also equal to which of these intervals for the variable x. Okay, so let's get our calculator up. Okay, so we're just going to work with a standard normal distribution first. So the lower limit is -2 and the upper limit is 1. So there's our probability. Now we can go through and actually check which of these is equal to that. So I'm just going to go and do the same thing. Probably don't need to keep going to it. All right, so our lower limit, if we're doing the question A, is 18 to 21. And our standard deviation was 6 and our mean is 20. I might just make sure it is 6 underneath our calculator. There it is. Okay, so there's the probability for that one. So let's just keep changing our lower limit and our upper limit. So 14 to 32. So the mean and standard deviation stay the same. And you can see they're now equal. Okay, so we don't really need to go through the rest of them. Remember, in an exam, we're going to be short on time. If you wanted to check any questions, just put a little asterisk next to it and just say what you need to do. So check C, D, E answers or something like that. All right, so just whatever it is that you need to do at the end if you've got time. Otherwise, just move on because you don't have time to check the others. You just got to be confident in your answer. All right, moving on to question 2. So pause if you want to have a go at doing it on your own. So the continuous random variable x with probability density function px has mean 2 and variance 5. The value of the definite integral from -infinity to infinity x squared px dx is equal to. All right, so just so you know, the previous question, the percentage of students who got it right was 51%. Okay, so it wasn't too bad, but this question here, where is it on my sheet? 46%, so probably not an overly difficult question. The key here is looking at the mean. So think about the formula for the mean for continuous random variables and the formula for variance, and use them to find that definite integral. All right, so have a go if you haven't already paused. All right, so just going back to your notes, which is, I'm looking at it from the textbook, but you do have these in your notes. So the mean for continuous random variables, you can see there in the green box. And then if I just go to the next section, we'll have the variance. Okay, so just using this formula here is a little bit easier. So E of x squared minus the mean squared, and remember the mean we also write as ex, the expected value. All right, so I've just written the formulas there on the page. So your expected value for this one is the same as your mean, so 2, and your variance is equal to this, and remember your variance is equal to 5. So let's have a look at what we want to know. So we want the value of this, which is the same as EX squared. Okay, so that's basically what we're solving for. So we're solving for this. Now I know that my mean is 2, so that's going to be 2 squared equals 5. So we're just solving this quite easily by hand. So 2 squared is 4. So bring that over to the right hand side and we get 9. All right, so just being familiar with the expected value formula and the mean, which is your expected value. Okay, so just when you see mean and variance and standard deviation, just understanding those calculations. This is continuous random variables, but you can have discrete random variables as well. All right, let's move on to question 3. So a part of the graph, now we're just going to make sure our domain, okay, so we're looking at any real value, g of x equals x squared minus 4. So it's a parabola that's been shifted down 4. So it's shown below. The area of the region marked A, so this area here, is the same as the area of B. I kind of feel like I've done this question before. All right, and we've got to find the value of A. So first of all, it is a parabola. So I know that this point here going through the x-axis is 2, and this is negative 2. Whoops. Okay, because it's x squared minus 4, so if we were to solve for the x-intercepts, there it is. So with your definite integral, we can do it from 0 to 2. Now, because we're below the axis though, you either have to switch the 0 and 2 around, or you can just put a negative in front. You're going to be doing it on your calculator anyway, and then g of x. But, you know, if you got a question like this that wasn't a multiple choice question, you should be showing your working, so it's important that you put the negative there. All right, so that is going to give us the area, but you can do everything in one go if you wanted to. So then that is equal to 2 to a of g of x dx, and you can just do solve on your calculator. So get my calculator up, might just put it over here. Now I haven't done any of these questions, so I'm kind of hoping that my errors are minimal. All right, so I want to put a negative in front, 0 to 2. Now g of x, what was it, x squared minus 4. Dx. Now with your cursor, remember you always want to shift it until it's a big one. All right, don't make that error in the exam. All right, and that is equal to the area of the section B, was it? So 2 to a, and oh, it's not hard to type in, minus 4, so same curve, dx. Get your big cursor, so see how it changes your cursor. So if I left it there, it's not going to work for you. All right, so we're solving for a, so comma a. We're not solving for x, we're solving for a. So there is a few values of a. So a is equal to 0, a equals negative 3.46, or a is equal to positive 3.46. Now, they haven't given us the answer in, given us the exact answer, which is fine because I can just go to standard and there it is there. So 2 root 3, so the answer is E. So nice quick one to do on the calculator. All right, and the proportion or percentage of students who got that one correct, oh, surely it's not 15%. Maybe it is. Well, there you go. If my notes are correct, 15%. All right, let's move on. I wonder what the most popular one was then. If it's 15%, they definitely went with the wrong answer. Okay, question 4. So we've got another definite integral question. So area between two curves. These aren't that difficult to do, but students find it hard to kind of understand that there is an equation of this line. Okay, so remember when you're finding the area between two curves, it's just your top curve minus your bottom curve. So there's our bottom curve and our top curve. Now that bottom curve, actually I might do it in a different colour. Do it in green. Okay, so the equation of my green is given here. All right, so that's f of x equals the square root of x minus 1. You probably wouldn't put all this working out on here. But your yellow line is just a horizontal line, so it's going to be a y equals some constant. Now they both meet at x equals 5, so I can just substitute that in. So y is equal to f of 5, which is the square root. Might do it over here. So f of 5 is equal to the square root of 5 minus 1, which is going to be 2. Okay, so this line here is y equals 2. So when I'm doing my definite integral, I've got going from 1 to 5. I put my top line first, so it's going to be just 2. And I'm going to subtract the bottom curve, so square root of x minus 1. And don't forget the dx on the end. So for that one, the correct answer is C. No, it's not, sorry. We need to go from 1 to 5. Okay, so, all right, so that's going to be a little bit annoying. So what, we can't then assume, oh, this is where it's good because you've got different options. Now, I know this isn't going to be an option, okay, because I'm going from 1 to 5 and it has to be that expression, which that clearly isn't. So what we have to do is then work out, well, what else can we do to calculate it? You can do this on your calculator and then see which other one is equal. Okay, that's a long way about it. But we could also say, well, let's look at our options. So if we look at option C, all right, so it can't be option C. Sorry, I'm just thinking, just pause because our terminals have to be from 1 to 5. Okay, so then you can go through and check if you wanted to do B, D, and E. It actually wouldn't take you that long to check, but you could also do the inverse. All right, and looking at the different options, that's what they have done. So what I might do, if I was doing this in exam, I would actually calculate this definite integral. So I might just quickly do that now. We're going from 1 to 5, and it's 2 minus the square root of x minus 1 dx. All right, and then I can just do the other definite integrals. Now you probably think, oh, this is so time consuming, but you're going to come across questions that you might not even know how to do or might be very difficult. So it's probably not a bad thing to spend time on questions that, you know, you will get an answer. It just might take you a while to get it. Okay, x squared plus 1. And then the last one must be it, but we can't assume. Okay, so 0 to 2 x squared. So we kind of debunked all the rest. So I'm saying it is the last one. There we go. So it is E. All right, but I'm going to show you how to do it using the inverse. So we can take the inverse of that, and that's what they've done to get the x squared. So at the moment, our equation is y equals square root of x minus 1. All right, so there's the function there, that curve there. So let's just take the inverse. So we switch them around. Now you can also do this on your calculator, but this isn't a hard one to do. So let's take the square of both sides. Oops. What am I doing? I have to switch them first. All right, so x equals, so we're finding the inverse. So x squared equals square root, no, y minus 1. So y equals x squared plus 1. And that's, always remember, you should write the correct notation. So f to the negative 1 of x equals x squared plus 1. So when you're doing an inverse, make sure you do that notation. All right, so if we're finding the area using the inverse, this point here, y equals 2, now becomes x equals 2. So we're going from 0 to 2. And this vertical line going through, oh, you can't see my pointer, let's highlight it. This line here going through x equals 1 now becomes y equals 1. So that's why we're going to be doing x squared plus 1 will be our top curve minus 1 dx. So then we're left with x squared plus 1 minus 1 just gives you x squared. Okay, so that's how you get that expression, but because we're looking at it being equal to, you can just check every answer. So we know how to find the area and then we can check it. These types of questions, there are different ways of asking them. Okay, so you do need to remember, okay, I can find the inverse is one way of doing it. All right, let's move on to question 5. So that question there, the proportion of students who got it right, let me just have a look. 21%. And I would say the majority would have chosen C, not notice those terminals. Okay, so just be aware of little things like that. Okay, so question 5, for events A and B, the probability of A and B equals P, and the probability of not A and B equals P minus 1 over 8, and the probability of A and not B is 3P on 5. If A and B are independent, then the value of P is. All right, so have a go at doing this question on your own. I would set up a two-way table probably just to get an idea of where all the values sit. So yeah, pause and have a go. All right, so I've filled in the two-way table with the information we have. Now we don't really need the other cells. Oh, actually we do. All right, I do need to be able to use the independent, okay, so they're independent events. So you need to use this formula. So the probability of A and B is equal to the probability of A times the probability of B. So we know the probability of A and B is P, so I'm going to put that in here. But the probability of A has to go in this cell. So we're going to have to do P plus 3P on 5. Okay, so that's the probability of all A. And then the probability of B is going to be P plus P minus 1 over 8. So let's just do that here. So A is P plus 3P on 5 times P plus P. Now you can simplify it. Sometimes I think when you simplify it though, you can make small mistakes. You can easily solve this by hand, but girls, it's exam 2, so let's do it on the calculator. All right, so solve. All right, so your first bracket, P plus 3P on 5 times p plus p minus 1 on 8. And we're solving for p, so comma, oops, no, it's equal p. Got that part at the start, so equal p comma p. Because remember the p in my equation at the beginning. Okay, so p equals 0 or p equals 3 over 8. So we can't have p equals 0, otherwise everything would pretty much be 0. We'd have no event A or B. So your answer is going to be C, which is 3 over 8. And let me just see what that one was. 51%, so not too difficult. All right, so setting up a two-way table, if you had to, remember they all add up to 1. So you can go on and calculate the others if you needed to, but in this question we didn't need to. All right, question 6. A and B are events of a sample space. Given that the probability of A given B equals P, probability of B equals P squared, and the probability of A equals P to the power of a third, probability of B given A is equal to. Just before I move on, sorry, I just realized what I wanted to say. Question 5, the independent events equation is not on your formula sheet. Okay, so I did check that before I did that question. And then I had to Google it, but it should be in your notes, okay? Now, conditional probability is on your formula sheet. Okay, it should be in your band reference as well. So for this question, have a go at it. If you want to, you can set up a two-way table. That's how I'm going to approach it. So press pause and have a go at doing it on your own. Okay, so I've filled in the two-way table. Now we don't have enough information to get A and B, but we do have enough information in the question to work on. So we know that A given B is P. So I'm going to substitute that in here. So P is equal to. Now at the moment, we don't know what A and B is, so we don't know what this value is here. So I'm just going to call it X, just because I'm not going to keep writing that down. So X over the probability of B is P squared. Okay, so now I'm going to just move on to the, oh, actually, before I do that, so if I rearrange this equation to get X on its own, X is equal to P times P squared. Okay, so I'm just solving for X. So bring that P squared over by multiplying by P squared. So I get P cubed. So in here, actually I might leave that X there. X is equal to P cubed. So now I've got P cubed, I can work out the probability of B given A. So the probability of B and A is the same as A and B, so that's P cubed, which we just worked out before, over the probability of A, which is P to the power of 1/3. Now, you can do this by hand if you can remember your index laws. So just 3 minus 1/3 gives you P to the power of, oh gosh, we've got to do it as 8 over 3. I just cheated and looked at the answers to give me some inspiration. So there it is, D. So that question, I'm going to eventually lose track of which ones I'm doing. It was 49%. Just make sure I got that. Yeah. Looking at the right one. So 49%. Okay, so two-way tables I love. I'm not a huge fan of Venn diagrams, but two-way tables, I just find you can work with them to find out what you need. With this one, we didn't really need to, but it kind of sets out the question. This question here, it's multiple choice, but you could see it on exam 1 because it's a question you can do without a calculator. All right, moving on to question 7, another probability question. All right, so John and Rebecca are playing darts. The result of each of their throws is independent of the result of any other throw. The probability that John hits the bullseye with a single throw is 1/4. So let's just highlight that. Hits the bullseye is 1/4. The probability that, so that's John. Rebecca hits the bullseye with a single throw is 1/2. John has 4 throws and Rebecca has 2 throws. The ratio of the probability of Rebecca hitting the bullseye at least once, Rebecca hitting the bullseye at least once to the probability of John hitting the bullseye at least once is. Okay, so a ratio we're just going to do on the left-hand side for Rebecca. So I might let the probability that Rebecca hits a bullseye be X and John be Y. So we're going to have the probability that at least once, so X is greater than or equal to 1. Now it's a ratio, they're not equal. So the probability that Y is greater than or equal to 1. Now remember that is... So I'm just thinking we could use the binomial, so we don't really have to do 1 minus. Okay, if you were doing this without a calculator, you could just do 1 minus x equals 0 and 1 minus y equals 0. Okay, so go ahead and have a go at doing that. You'll need to use the the binomial distribution. All right, so we're doing Rebecca first, and it's a bit annoying because John was written first at the start of the question. So binomial CDF. So we want at least 1, so lower limit is 1. Remember, for discrete probability, it does matter what your lower limit and your upper limit is. So if she wanted more than 1, we couldn't include 1. All right, so she's only having 2 throws, so she can only get a bullseye once or twice. Number of trials is 2, and her probability of success is 0.5. All right, so there's her value. So I'm going to write that here, 0.75. Where's my calculator again? Okay, and let's do John. So he wants at least 1, but he's got 4 throws. So his upper limit is 4. Number of trials is 4. And his probability of success is 0.25. Okay, so 0. And I've got this on standard, so it's actually probably a terminating decimal, I'm thinking. 0.6, whatever it is. 0.68, blah, 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 blah. Now, as you can see, it's not any of these ratios, but we can do process of elimination. I know it's not going to be A, and I know it's not going to be D. Okay, so 1 to 1 would mean they have to be the same. 2 to 1 would mean that the first one would be bigger, by twice as big, sorry. The first one is also bigger, so you want your first number in your ratio to be bigger, so it can't be C either. So we're looking at between B and E. Now the easiest way to do that is just to take the 2 numbers and divide through. So I'm going to take the 0.75 and divide it by this second value. And I'm just going to put it on decimal because decimal just makes it easier to compare. All right, and then I'll go to 32 over 37. So option B, so 27. All right, so not the same. So let's try E, and hopefully it's correct. 192 over 175. And you can see we get the same value when we divide it through. So your answer for that one is E. Oops. I wanted to highlight you. Okay, so for that question, 37% of students got it correct. Probably, I don't know, because I don't think it's a hard question. So I wonder which other option they chose the most. All right, we've got another probability question. So many probability questions that are difficult. If x is a random variable such that the probability that x is greater than 5 equals a, and the probability that x is greater than 8 equals b, then the probability that x is less than 8, given that x is less than 5, given that x is less than 8 is. Okay, so I'm just wondering what we can do. Okay, so if we've got the probability that x is greater than 5 is equal to a, that must mean the probability that x is less than 5 is its complement, so 1 minus a, and then the probability that x is greater than 8, I remember doing this question, this must have been on one of the VCAR quizzes, is less than 8 is equal to 1 minus b. And then we have to use the conditional probability formula. So x is less than 5, given that x is less than 8. We want the intersection between the two. So x is less than 5, given that x is less than 8. So that must mean what they have in common is x is less than 5 over its condition, which is x is less than 8. So we're going to end up with 1 minus a over 1 minus b. I remember doing this question because that wasn't one of the options. So we had to rearrange the expression to get it to look like one of these. Okay, but we can do a process of elimination. So I know it's not going to be a over b. It's not going to be this one because you can't have a b. Actually, you could if you multiplied. Yeah, no. All right, it could. What we can do. All right, we've got 1 minus a over 1 minus b. All right, so what I'm going to do is just multiply. Just thinking how I did it last time. It's funny, if you look at something long enough, you realize what you need to do. Okay, so what I can actually do is multiply by a fraction. Okay, so you can always change a fraction by multiplying by a number that is equivalent to 1. So I can actually multiply this by -1 over -1, which is still 1. So what actually happens now is if I put that 1 minus a in brackets and we're multiplying it by a negative, and I do the same for b, or 1 minus b, that negative multiplies in through. So I end up with whatever was positive now becomes negative, and whatever was negative becomes positive. So that negative a becomes positive a. So it's a minus 1, and that negative b on the bottom becomes b minus 1. So the answer for this one is E. Okay, so just a little trick on the end there, which was so frustrating. But if you needed to if you got stuck on this one, don't doubt your answer because you should be quite confident with that. I would go through and do a process of elimination, and you probably end up with E because you don't really want A or B both on the numerator and the denominator. And C, we can see it could be, looks similar. Okay, it's just A and B are around the other way. Okay, so I'm just wondering if you could also do substitution. Yep, you could also substitute in a value for A and B also. Okay, let's move on. So question 9, a part of the graph of x squared. So always check when you're given a rule, the domain. So there's our domain, there's been no restrictions. If there has been restrictions, you really need to take care. So that's why I think it's important to just note the domain. Okay, so as shown below, Zoe finds the approximate area of the shaded region by drawing rectangles in the second diagram. I have a feeling I've done this question before as well. So Zoe's approximation is p% more than the exact value of the area. The value of p is closest to. All right, so let's find the area of the first one. So remember, the area of this is just a definite integral. We're going from 0 to 6 of x squared dx. For the area of the second one, we do have 6 separate rectangles. They do have a width of 1, which is great. So you can just go 1 times. You don't even have to do the 1 times, but that represents the width. So if it was a half, it would be a half times. And then we're just substituting in each point. So this point in here, this one here, okay, to get the height of your rectangles. So the first one, we're going to have 1 squared. Okay, so the area of this first rectangle is actually 1 times 1, which is 1. Okay, the next one we're going to have 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared. Okay, so the area of the last one is just 1 times 6 squared, which is 36. Okay, now you can easily do that on the calculator. You can probably even square them. So it's going to be 1 time, so I don't even need to do that. So we can just say 1 plus 4 plus 9 plus 16 plus 25 plus 36. There it is, it's 91. Oh, I was going to say pause it. I didn't want to keep going. Obviously you can pause it, you don't need me to tell you to pause it. All right, so there's the area approximating. If we're going to use the definite integral, we're going from 0 to 6, and it's x squared dx. Right, so it's 72. All right, so her approximation is p% more, so the difference between the two what is that, 19? So 19 over the exact area, which is 72, whoops, multiplied by 100 just to put it into a percentage. So 19 divided by 72 times 100, and we get 26.39. All right, I did just have to check the answer. Even though it says is closest to, I didn't like the fact that it wasn't that close to the actual answer, but the answer is D, 25. And when I went to the assessor's report, my working out is exactly the same. So closest to 25%. I'm wondering if the reason for that just going up in multiples of 5. But yeah, I don't like the idea that the answer, if it was 25.39, I would be a little bit more happier, but anyway. All right, moving on to question 10. So question 9, 43% got that correct. So I think even, actually, looking at the diagram, you could clearly see it's not 10% or even 15. So remember, you can always, if you have no idea how to answer a question, always answer it, but do a process of elimination first. So for this question, if you had no idea, you can get rid of probably the 10 and the 15 and choose between 20, 25 or 30. Okay, question 10. Consider the region bounded by the x-axis, the y-axis, the line with the equation y equals 3, and the curve with the equation y equals log base e x minus 1. The exact area of the region is. So we want x-axis, y-axis, and the line. Okay, so this question here, if we just think of the graph, just quickly. So we've got the line y equals 3, which is here. And our log graph now, they'll eventually cross at some point. So you do need to know this point here and this point here. All right, so these 2 points are going to be your definite integral. Because we want to find this area here, all right, we do need to find, and that might change, I just need to graph it actually. All right, so pause if you like, just try to find those x values. So this, the first point is just your x-intercept of your log graph, and the second point is the intersection of the two lines. All right, so to find your x-intercept, I'm just going to use solve. You could probably graph it also. I'm just wondering. Oh no, you can't graph it because it's not an exact value. I mean, it is an exact value, but your calculator won't give you an exact value. All right, let's do our log. All right, so remember ln is the same as your log base e. That is equal to 0, x. So your x-intercept is there at 2. Thanks, highlighter. 2. And then the next point is the intersection. So get my calculator back up. I can use the same expression, so I can just highlight, drag down, and it's equal to 3. Now I've got it in decimal. Let's change it back to standard so we've got an exact value. So e to the power of 3 plus 1. All right, so your definite integral is going from 2 to e to the power of 3 plus 1. Now we have to do it the line 3 first, y equals 3, minus the log. All right, and we can just do that on the calculator. Oh, don't forget your dx. Even though it's just working, it's a good idea to always remember to put that on. Okay, so definite integral, we're going from 2. Now I'm just going to highlight this and drag. I love the highlighting and dragging. I can even put that down too. I forgot the 3 minus, so I'll do that here. Just be careful when you're subtracting. If you've got multiple terms, put it in brackets, but we're just subtracting one log, so that's fine. Dx. All right, so we might have to do a little bit of tidying up there because it hasn't given us an answer that's there. So let's just check everything is okay. So going from 2 to e to the power 3 plus 1, 3 minus log base e, x minus 1. Okay. So I'm going to just pause, oh no, I won't pause. Negative 3 e to the power of 3 plus 4 e cubed plus 1 minus 8. All right, so I'm going to expand that bracket. You can actually expand on your calculator, but I don't think it's going to make any difference, to be honest. I can never remember what I need to, before I expand, I'll just highlight the expression to copy it. Sorry, expand. Did it expand it? I don't know whether it expanded it. There we go, e cubed minus 4. Well, oh, that's not one of the answers. Gosh, I realize what I've done, and I can just quickly do the calculation in my head. This area here I forgot. Oh my gosh, why did I think I had that previous question in my head that we did earlier. Okay, so that was my error. So let's change that. That should be 0. Okay, so that's good. Let's get rid of all this because that's just nonsense. We don't need that. All right. Sorry, girls. So we do need to change that to a 0. Change you. Oh. Oops. All right, the reason it's undefined is because when you substitute in 0 into that log, you're going to have negative log. So what I might do, sorry, thinking on the spot here, is we can actually put a line there. I'll go back and do what I originally had, which was from 2. And remember we had e to the power of 3 minus 4. And what I can then add on is just this section here. Okay, and that's pretty easy to just quickly calculate because we have a width of 2. So there's our rectangle, width of 2 and a height of 3. So your area of that rectangle is going to be 6. So we can do e to the power of 3 minus 4 plus 6, which gives you e cubed plus 2, which is the correct answer. Now, when I looked at the solution for this, they did do the inverse, so the same way that we did one of the previous questions. So you could take the inverse of your log equation, right, and then you got an exponential, and you'll just, then your graph would go from 0 to 3. So taking the inverse, I might just quickly do it now. So we switch x and y, so I'm just going to write the expression first. So we've got x equals log y minus 1. Then to get rid of the log, I'm going to take the value of base e, of both sides. So y is equal to e to the x plus 1. So your inverse is e to the x plus 1. So with your definite integral, remember this, what I've drawn here flips. So your y values going from 0 to 3 now become your x. So x will be from 0 to 3. E to the power of x plus 1 dx. So you could also do it that way, and I think you would get e to the power of 3 plus 2. So that's how they've done it on the assessor's report. I'll just quickly show you. So question 22, so 45% of students got that one correct, and you can see they've found the inverse there. All right, so I'm going to stop there, and I'll do 2 videos, one for question 1 to 10 and another one for questions 11 to 22. All right, bye.